Hey everybody, we got Ben here. Who else we got here? I've got a strawberry, banana, vanilla kind of milkshake. So I might just, matches my shirt today. Your drinks have to match your shirt. It's my lunch today. Good to see you here, Ben. Mubot's in the chat as per usual. Turn on some relaxing music. I don't have that many songs to play. That's all. I need to download more music. Here, we'll try a different one. Chill. These are too hype. These are too hype. I don't know. Have you tried adjusting the frequency? Mine fails with certain data at certain frequencies. Yeah, that could be it. Can you go over how to remove insignificant variables from rules when you get a chance? We'll do the is dot significance. Great question right there, Aaron. So the notes are in the notes, but we'll do that next. Let's look at this. Let's look at Ben's problem. He said he sent me on Discord. So let me go up here to the chats. Benjamin right here. I have a problem plotting my seasonality. Okay, I've got it pulled up. Running the code. UI not found. Oh, Ben, we got a problem. Double check. Ben, you might want to save what you have, like your environment. Your UI is crashing on me. The UI is crashing, Ben. Let me see where it's crashing. It says cannot summary.rmd. Oh, okay. It's I don't have your summary file. Can you send me your summary file real quick? Then we'll look at Aaron's question here in a moment. Kayla is the master. Let me send another file. Yeah, send me the summary. I tried the insignificant, and I think I have a small mistake somewhere. You bet. We'll look at that here in a second, Aaron. Aaron, thank you so much. People are here ready to work. I just got my lunch. It's good lunch. Getting healthy, getting strong. Is there a correct way to do the time series difference log variable? Just thinking over. Yeah, I think so. Let me double think. Yeah, because we want to take the log first. That'll pull in the extreme values, and we can do the difference of the logs. Yeah, and if we do the differences, then we log those. We might get the same way. I would look at the outputs. I would take a look. I did this. I was doing this earlier, and I think one is... So if we log it first... No, you might want to difference it and then log it. Because you can get the differences and then log the differences. No, but if we transform the time series, then we could take the difference of the transformed and then we could base and then we can untransform it. Yeah, I would probably do it that way. I think Kayla would do it the way you're doing it, and then you can untransform your values back and then you can get the predictions from it. So I would do it. That's what I was doing today. So if you looked at what I did today in class, I box Cox transformed it at first, which is a lambda transformation. We've gone over how that works. It's just an equation that is basically doing a log of sorts. It's going to pull in the more extreme values. So I transformed it to begin with, like you're doing there, and then I ran it through things like ARIMA to do it. We'll take a look at Ben. So Kayla, you are correct. I would probably do what you're doing right there. I think that's a pretty good way to do it. Yeah, I would transform it first. Getting Ben's file right here, Ben's summary file. Okay, now I was like, why won't it work? And then the UI didn't have. Okay, so you're saying the seasonality isn't working. Let me take a look here, and then we're gonna do Aaron's question next. I'm trying to figure out how to code the difference in the log if diff no log. Oh my gosh, yeah. Yeah, just run it through individually. So Kayla, what I think you need to do is go to the very start of it. When you take your time series vector, put an if on it, and then have it make another reactive object that will pass through the later things. So many ifs, yeah, I know, right? It really is. But I would, when you create your time series object, then I would then have an if and have the diff, if diff is true, then change the reactive time series object to a difference time series reactive object. Does that make sense, Kayla? So I would, and then your code later on, or you could just change your initial take of it and then use the same code so you don't have to change stuff by calling your first something different and then making the difference object this. Like if this is true, then difference it and store into. I know it's fun, like recoding it, right? You just get more and more practice. My episode. Oh no, don't worry. This is like we're all learning here. Kayla's pushing my knowledge. So yep. Seasonality's not working, right? Okay, let me load in a file. Okay, data are not seasonal. What's mad about that? Hold out. Nice job. It's looking good here, Ben. Looking great. Frequency. Johnson & Johnson data is monthly data. Data are not seasonal. Okay, so I think your frequency might not be connected, Ben. Let me see what frequency is called. Do you have your permission to show this? Oh, I see it. I know the issue. So Ben, do you have your permission to show this? I think I can fix it. And I think I know what the issue is. And it's little interesting when we see what's going on right here. This might help other people. I wonder if I could do time series diff. Yeah, that's what I'm thinking. Like maybe you could overwrite it. Try that. Try overwriting it and then just have it overwrite it. In theory, you should be able to overwrite. Yeah. In theory, you should be able to overwrite the reactive object. And it should run in order. Theoretically, I mean, worst we do is we crash it. Worst thing that happens is the code crashes and it's like, whatever. Okay, so one thing you might not realize, and I might be able to show this here, but the way, and I think this will, I got to run the debug. I think this will show up in the debug mode. So let me get the debug mode turned on. This is something Kayla and I have installed. It really helps with some higher order debugging, but I've seen this issue before and I know what's going on with what you have right there. So you're basically right there. We're going to fix it in like this amount of time. You'll be like, no way. The debug mode is going to show the issue though, which is going to be the way in which that object exists. So because we're using an input, that object right there, let's go put in our data. So we just loaded in data. And let's go over here to the customized time series and change the frequency to 12. Click outside, change the frequency to 4. And then let's go and look at the debug mode. And we're going to look at just how this object is being handled. There's a lot going on this screen. And we should be able to see where we're changing the frequencies. I think that's where the data was loaded in. Let's go over to this step. And is it not showing me where I did that? Where is it at? I think this is it right here. Wait, input, quote. Where are you at? Why am I not seeing it? Ooh, it should be registering on here. Let me make sure it's registering. I should see it. I know what the issue is. You should, I think, yeah, the guy who does it in the demo does it on the Mac. So it'd be Command F3 on the Mac. So you can get this debug mode on the Mac. I just call it debug mode. It's shiny. I could look what the code calls it again. The issue is where it should be under an input. I'm a little afraid it's not seeing it. We'll look at where it's seeing it. The issue is right here with the frequency. The way it's taking in that frequency is a what? Which you wouldn't think this. You'd think, well, it's 4. But how is it taking in this frequency right now, which is a little counterintuitive? Does anyone know how it's viewing that? Which I was trying to show in the debug mode, but that is 4. We do want 4, but how is it seeing it inside of R right now? How is it seeing it inside of R? Like when R takes this object in, it's taking it as a what? You would think it's 4. I mean, it is 4. The issue is it's a character. The issue is it's taking it as a character. So we want to go around this and go as numeric. And that should fix it up. So it's that small thing. Go away. That should fix it up. It's taking it in as a character. And so we're going to go around it and put a numeric. Exactly. Fingers crossed. Hopefully it fixes it up. But just the way it takes it in. And I don't know why we're not seeing it. I don't know. I need to practice using the debug more and more. Let's go to the customized time series. This is monthly data, I believe. It's Johnson & Johnson's quarterly data, right? Oh, not quarters. Let's go to seasonality plot. Data are not seasonal. Let me look at where the objects are. Okay, so there's the input frequency. All right. Here's where the train data is made. This is the issue. Do you see it? There's an issue here. Very small issue. Do you see it? I pause here so we can see it because this is an issue. Don't worry, don't worry. It's like, oh, it's an issue, bro. What's going on? What's going on here? It's a very small issue. Mubot will tell us the issue. Mubot, tell us that issue. That's the issue. Very, very small. Mubot, what's the issue? He's going to tell us in the chat. This is capital F. Ooh. Oh, no, that's not the issue, Mubot. You gotta Mubot.
I am Mubot.
Just, you don't know what these things are, Mubot. Mubot needs practice. So I think that's also why we weren't seeing it. I think that's why, because I was noticing, I was like, why aren't we not seeing this? I'm going to load in the data again. Capital F, just destroying everything. One little capitalization, the whole world goes crazy. Not a good joker. I know, I've done that a million times too. It's these little things you just have to be very careful. And we go over here, we put in frequency now of 4, click outside, go to frequency of 12, click outside. And I think this is why we were not seeing it. Going through the process right here. We're still not seeing it, so I'm a little worried. Spend hours trying to fix it just for a capitalized F. I know, right? No, that's all it is. Or hopefully. The answer is it working now? Data are not seasonal. Let's hard code in a 4 just to see if it's taking it here. We're going to just hard code in a 4. If Brian knows how to spell. And we're just going to hard code a 4 in. Okay. Because the Johnson Johnson is... So we're just hard coding a 4. If... We'll figure out if that's the issue. So we're just hard coding in a 4. It's not liking it. So there's something going on right here. The time series is not changing. So that where I put that in, that's not impacting the time series. So we just found out that that is not work. That's not where we're grabbing this. So this is where we have to take a moment. So that's not the issue because that is giving it a frequency. This is the TS data right here. What plot is doing the seasonality? Let me go look at the seasonalities being done. Here's the seasonality. Seasonality is being stored right here in the GG season plot. The TS data. We got the auto plot. Let's see if the auto plot is running. Oh, no, this is the way it goes. This is the way coding works. Let's make sure the auto plot is running. We will be going over looking at Aaron's question here in a moment. Sorry, Aaron. I'm making sure the auto plot. Oh. What does that button do? Okay, so I think plots are working. So this is the... Things might be working. Brian just might not be that smart. Cross your fingers, everybody. Sometimes it's user error. Data are not seasonal. You're describing the time series plot. Warning, data is not seasonal. Well, why don't you look at this data? Auto plot, time series object. Is it not? That calls it. Yeah, don't want to do that. Two seconds. Okay. So the page is working. It is sending output. I'm just debugging right now. It's not even frequency 12. But so man, something about this time series object. So we confirmed the page is working. Does this make sense what we're doing right here? Like, hey, Cliff, good to see you. We've confirmed this is sending to the UI. Does that make sense what we're working on? Like, you have to look at the process of how we're doing this. We're just literally testing every path along the way. We have confirmed that it works right now and it's sending to the UI. So the problem is the object we are sending. If we get the right object in here, so let's undo time, bring it back here to this. Something's wrong with this. It must be the react. Exactly. That's, as Kayla's noticing, we're just narrowing down. It's the reactive TS data object is not carrying through the seasonality on it. And so we now need to go and look at this reactive object where it's called in different spots. So we're just going to go through. Here's the first instance of it. Okay. So we're taking the TS data reactive. Let me look here, make sure it's not called in other spots or like saved over. Looks good. Okay, this is the where it's created. I see it. I see it. I see it. I see it. Kayla, do you see it? Take a moment right here. See if you see it. 30 seconds on the clock. Do you see it? The answer's right there. Yep. I think Kayla see it. Sees it. 2 seconds. I'm going to take another turn. That's the answer right there. The answer is this. Yep. So that's the answer right there. Sure, we'll do this. Make us a little party. There we go. Okay. No, the comma doesn't go there. What am I doing? There we go. Oh, it's mad about this now. That's right. If you want it to look like that, that's all right. Okay, so now the frequency is a separate argument. So the problem is that frequency was being used as a concatenation inside of here. Coding is so fun. I can't tell if that's sarcasm or seriousness. But that was the issue. We just had the frequency as an argument inside of the start argument concatenate. So you got, I mean, this is its own function right here. So we had it as one of the arguments inside of the concatenate, and it needs to be its own argument inside of the time series function, because right here is where the time series closes. Yeah, I don't like that space. Go away, space. I don't put spaces there. Okay. So if we've done this correctly now, everything should work. Cross your fingers. Load up some Johnson & Johnson data right here, and then we're going to hop over to some 474. I'm going to find the data eventually. So much data. Okay, we're going to load up the Johnson & Johnson vector. Let's auto-plot it. Time series plot. Looking good. Let's go to our customized time series page. Seasonality 4. Ah! We did it. 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 Man. Whoo! Gotta find where that pipe's busted. You go through, you check for leaks along the way, you find that leak, you say, that's where the leak is, you fix it. So smallest of errors, sometimes hard to find. Thank you, Ben. Kayla, you gotta look for these things. I'll be like, so we had a few disconnects. We had a disconnect on the capital F was a disconnect. We had to turn the character into numeric. So here's your steps. I'll let you do them here. So there's a capital F for the frequency. That needs to be lowercase f, or just make sure they're consistent. We need to turn the frequency input into a number because it needs to take a number input. And then we need to move the frequency out of the start argument into its own argument by itself. 3 steps. If you get confused, message me. Maybe work on it. Let's head back to the main screen, do some 474 practice. Here we go. So that's a good moment right there, getting that seasonality plot working. Almost done with my lunch here. And like these problems, that's why it's pretty tough. They can take like sometimes 10, 15 minutes to decode because you're really just, figuring out where that pipe's broken, testing for leaks, putting some water on it, looking where it's bubbling up, do a little home repair. Let's go take a look at the question was, Aaron asked a question earlier. Aaron's question was, thank you, Aaron, for asking that. Sorry it took so long. I tried the in dot significant. And I think I have a small mistake somewhere. Let's go get that homework. Homework 7. Okay, so let's get homework 7 up and going. And the significant. Okay, let's look at how to get those significant rules and all that good stuff right here. Homework 7, talking about if rules are significance. It's problem 1C. Let's go take a look. And sorry, I'm pulling up the homework. Thank you, Aaron, for waiting. Hope everyone's having a good day today. I've been making like these healthy shakes for like lunch. Oh, I had this open earlier. Homework 7 we were doing earlier. But bananas, strawberries, oat milk. Never thought I'd like oat milk. That's good stuff. And chats are back up. Let's try some oat milk. Good stuff. Save the planet. Maybe. I don't know. Not saying if you want to save the planet, but... Okay, 1C. So we have right here... No one took the way to do it. Let's just look at the way to do it right here. Boom! Just to make sure people see how to do this. When we create our rules, we can go to the rules. And rules are just like a vector right here. And we have right now that we're just removing out the redundant rules. Because sometimes you get rules with the same sort of things. Like if you have like, how does buying A, B influence buying C? How does buying B, A influence buying C? Same sort of rule. Right here is the is significant, which is going to run and find out if they are significant using the rules and on the transaction data set. And it's just going to tell us is significant or is not. This will return a logical vector right here. We need to go and make these rules though. So we got the a priori learning method. Let's go ahead and do the a priori. Build a rule set using the support of this right here. So we could just say support. Yeah, let's go do that. Let's go here and go support. Support equals to that. This graphical error, don't worry about it. Won't occur again. There we go. It's because I got this all crazy over here. No more graphical errors. And a minimum level of confidence. So we should be able to go here to confidence. Let's go to con min and put a minimum level of confidence of 0.75. Now I'm doing this to make my life a little bit easier. We should have everything. Unhashtag this out. Rules for 1C. We're going to overwrite these right here. So we're kind of like whittling them down in a moment. What do we want to subset? Music. Let's go load that music data frame in. Music data frame's already loaded in for us now. I'll show you once again. This runs all chunks above. So I'm loading in the music transaction data frame. We were asking earlier, is it a data? I call it transactional data. It's an S4 type of transactions from the A rules package. So it's transactional. I wouldn't call it a data frame, even though I might say that. If I call it a data, oh, you didn't have music? Yeah, it can be that small right there. So seeing that, like, do the notes have an error? I feel like the notes might have an error on this because it shows how to do it, and I feel like they might have changed this because sometimes they'll change a little something on us, and then we have to update our code. Aaron, 50 points right there. Aaron, I feel like you just saved a lot of people a lot of time because I feel like the code does on the slides have an error. Sorry about that. That's why Brian does minimalistic slides when he makes his slides. I'm just kidding. Music is what we're taking and doing the a priori learning method on. List. So we should have right here for the list. And once again, probably the easiest way. I'm always afraid of making my typos. Go right here. And we got here the list. It's not going to show us. Ooh, they don't like showing how to do it. List equals support. There it is. They always abbreviate these things, and that drives me nuts. You got sup for support, conf for confidence. So if you don't type those in properly, you know what? There's an interesting thing inside of R. I want to show you something, and it might work. We're going to do this the right way, then we're going to try it the wrong way. We're going to go sup. You see, you don't get the autocomplete. You got to know it's sup. And sup is going to equal our support that we saved outside of here. And then this is a list, so we can put the comma for another thing inside the list. And con is conf. It's not confidence. I don't know why they didn't spell it out. Someone got lazy, and they don't have the autocomplete because it's inside of a list. I almost just wish these were different arguments. They thought that'd be helpful. I saved this as something as my confidence minimum. You could literally just take these values and put these values inside of here like that. Same thing. I just called them outside, so maybe I can manipulate them, especially when I make a Shiny app. Object support not found. Oh, haha. Let's run those. There we go. And we didn't turn verbose to false, so we get all this extra output. So we saw this in today's code. The verbose, so you didn't see it off, or you didn't see it like that. It's not verbose. Really, your autocomplete's not going to do it? It is verbose, unless I'm going mad. Where is it? Control. Oh, it's control. And that's where you handle the verbose. So you have to go control. And then object of class AP control. And really, they make it... Oh, we're not searching the topic right now. Control equals null. They're not even going to turn off their verbose. Okay. Control equals verbose. Is it list? Control is a list with verbose equals to false. Yeah, and that's what it is. I do not like the way that, yeah. So just take a look at the two ways I'm running this right here. The control is also a list because there's just more controls. That's why people do lists a lot of times, so you can just do multiple things. You don't need the verbose. Yeah, I know, right? Because they're like, hey, I got this big control panel of these things you can put in. You can be like, I want to do da-da-da-da-da-da-da-da. And you just do like a whole list of things you want. You just hand it a folder and you say, here's the controls. You hand it a folder and you say, here's the parameters that I want. So it's just a way to enter in multiple things. It's like they're condensing their arguments. They just don't want an argument for support, an argument for confidence. They want a control where you can do more things. So, yeah, my music like didn't change after removing the insignificant ones. Then there's no insignificant. Yay! That's like sound effects. That's like one of my favorite ones. It's just so cheesy. I'd have this set to false. You don't need to see that. Like, we don't need to know all that. This is good stuff right there. Diagonal stuff. So now let's go ahead and remove the redundant rules. First off, one thing I want to look at is I want to look at the length of my rules. This just tells me how many rules I've created. That many rules. We're overwriting the redundant rule. We're overwriting our rules now by removing is not redundant. So if you looked, we've whittled down our rules some right here. And so this is what Aaron's asking about. Aaron says that they've removed they're only the significant rules. This is a test right here to see if the rule is significant. It looks like it's all true. So only things that are true will be returned, as in it is significant. And I think that did not change. 6754. If you're using controls up here that are somewhat reasonable, like if you do something ridiculous like this, don't do this. See, now it's taking longer. I just wanted to relax. Don't do that. Did I say don't do this? I meant don't do it. This is why we use a priori, once again, because now Brian's computer is going to explode. Once again, very good modern computer right here. This is the point of the a priori learning method, to not do this. I'm actually still using... I'm getting choked up, guys. Guys, everyone. It's just so sad that this is taking so long. The a priori learning method will go in and remove things that do not have enough occurrences. Oh, not enough memory. Oh, look at it. It's telling me what the heck. Look, good stop messages. We know, like, someone who wrote this wrote a stop message in there. And let's just go here and put stop and put this right here. So someone literally went and their stop message wrote that right there. So they, good job on that person who made this code to say increase minimum support. They know how to put a message to tell somebody something's wrong. Good job. Because, yeah, they're right. I shouldn't have done that. Right here, Trace is asking, is this how you would set up the last part? I think so. Here, we'll throw that on here real quick. Let's take a look. Trace got some code here. He's inspecting the rules he's creating. So let's walk through what Trace has. I don't even know what the question is. Top 5 rules in Lyft. So Trace is sorting by Lyft, not Lyft space, if you watch class today. So Trace is sorting the rules by the Lyft. Decreasing equals true, so we can get the highest ones first. Remember, and we said this in class today, you do everything inside of the inspect. Once you get the expect, you can't start sorting. You can't sort the things. It's because what comes out of inspect is just a print to the screen. So it's words. You don't sort words. They just are characters. So I think this does it. I think you got it. Yep. If somebody listens to Britney Spears and Selena Gomez, they are super likely to listen to Miley Cyrus. Can anyone tell me right now, just take a second, what is the original probability of listening to Miley Cyrus? What is the original? 30 seconds on the clock, 50 points out there. What is the original probability of listening to Miley Cyrus? What is the original probability of listening to Miley Cyrus? Lunch over. Here is the confidence, as in, if you listen to Britney Spears and Selena Gomez, you have an 87.7% probability of listening to Miley Cyrus, or I'm thinking of the Lyft. I think you're right, Braden. We could easily figure this out if we go to item frequency and music, and we can figure it out a lot of ways. Miley. Boom, right there. Braden, great job. 50 points. I like this part of the song right here. It's pretty chill. Yep. And the way Braden got it right there was he took the confidence, divided it by the support, which is the factor increase to the original probability, and we see the same result. So Braden, great job. Great practice. Understanding what the output is showing you. Now we know when we see the lift, it's the increase to the original probability of the right-hand side. What questions do you have? Let's head over to the main screen. Think some good coverage right there. What questions do people have? Just working away. It's open floor on questions. We are question free right now. When you have time, could you show me the code to write the... Yeah. That should just be... Here, I'll show it real quick. Let's go to the main screen. So, to write the J&J, to write any CSV, you want to go to write CSV. You want to take something in your global environment right here, which I don't... None of these are really good ideas to write. Let me just go here right now. So you want to take whatever you have in your global environment, and I'll put some stuff in here. So the way this works, this will write it to name a file on my computer. Probably don't want to call it name a file. Probably want to call it something like stat survey. So this will write it as stats. Like that's writing to my working directory a file called stat survey. So this is object in global environment, and this is file name to write to .csv. Does that make sense right there? Whatever you have in your global environment, and then wherever you want to write it to on your computer, it just takes 2 arguments. You can also, it's like read.csv, but it's write.csv. And there is, if you ever want to write Excel things, you can just go to the library, if you have this one, the write Excel package, and you could go to write Excel. And with write Excel, you can write XLX files. So you could go right here and write an Excel file to be like survey 10. Someone wants it in XLS format, so I could go stat. I just call it, stat survey. And xls.x. It might do without that. And then if we go here and search on the computer, we go right here, we go search. What? Better exist. There it is. Let me close out these things first. Sure, don't save. I don't need that, right? Good. Are you on a Mac or are you on a PC? No, I see Kayla's got a question. Are you on a Mac or are you on a PC? Get a little nicer output. Are you on a Mac or on a PC? You're on a Mac. Hit Command Spacebar and type what you just saved. So whatever you called, just hit Command and then Spacebar. That'll do a global search on the Mac. So it's super helpful. Anytime you want to like load up a program, just Command Spacebar, RStudio. Command Spacebar, Word. You can load up Word. You might have on your taskbar down there. But Command Spacebar, then type the name of the file. It'll global search your computer. It should be in your working directory, wherever you're just working in right now. But Command Spacebar is global search on the Mac. Super helpful. Like, there's a few super really helpful things, and Command Spacebar is one of the probably the best things. Like, a lot of people don't know about it. Just if you hold Command and then you hit Spacebar, it'll come up with a search bar on the center of the screen, and that'll just let you globally search the Mac. Boom. Great job right there, Ben. Great questions. Let's see Kayla's question here next. You're welcome. Great job. Like, this is, we just practice and we get better at things as we do it. That's the way we do it. Ben right there, and everybody 50 points. Thank you for asking these questions, Ben. The only way to learn things is to ask things. I want people to remember this. Like, even when you leave this class, I'm having trouble getting my slider input to adjust the forecast window to connect. Send it to me, Cliff. We'll get it worked on here because we got Kayla's question, then it's open floor. So send it to me, Cliff, and we'll get it connected in here. And I'll send it back to you or show you how to do it. And then I'll just ask if I have permission to do it. I have the option to difference in log and boxcox. Would it be okay to use boxcox if difference in log are active? Or should I just do the decompositions instead of worrying about boxcox? Whew, Kayla, that's such good questions. I mean, allow it. You might even maybe display a message or something. Allow it, and just let people. I mean, I think, in my opinion, the more things you allow, the greater the possibilities. Now, you might do things theoretically you shouldn't do, but sometimes that's how you figure out the things you maybe like you never knew. So I think we push limits and we allow it. I sent you my app. Can you take a look at it after Cliff's? Yeah, let's do that, Thompson, next. You bet. So let's take a look at Cliff's right here. Cliff, do I have your permission to show your app on my screen? To show the code. If Cliff says I have permission, I'm going to get it pulled up right here. I can work it on the background. No one feel pressured to be like, you have to show my stuff. Cliff says I was getting an error. So it's with the window, right? Let me see right here. Okay. As long as Cliff says I have their permission. Let me go back and look. Absolutely, okay. Theoretically, would you use the boxcox on a time series with differencing and logging? You probably want to untransform these things afterwards, so you probably need some... Let me just say this, Kayla. I just want to put this out there. You pretty much have a 100 right now. This, you're just... I don't want you to go crazy. I want you to like allocate your time how need be. But your app is... I think people... I'm not... Yeah. I just want you to know that like... I'd be very careful because at this point we probably need to untransform. I don't see anyone really doing that. Does that make sense? I don't think you'd want to do that. You really want to stick to maybe one transformation, because if you transform data, you're going to have to untransform to bring back. Like today we showed how to bring back transform data because you want to bring it back to the context and see what your predictions are in the original context. So theoretically, would you use boxcox on a time series with the differencing and the logging? And you'd use the boxcox beforehand probably. And the boxcox is basically just logging. Does that, I mean, I'm not saying it is logging, but for all intents and purposes, it's going to achieve a similar goal. It's just trying to find the right value at which we should do it right here to achieve the lack of heteroscedasticity and all that stuff. Yeah. Just a matter of clicking a button on my app to do the transformation. Yeah, it's that. Oh, yeah. Gosh. Kayla, I mean, like I said, I want to show this and be like, this is what we were using. I'm like, that's a really cool program. But like, yeah, my student wrote it. So we're all here learning. And I really want to say great job, everybody. And I want you to feel impressed when you show people what you've done. So it's all about just thinking about how you can push those boundaries. Let's take a look here and let's get working. I think I will remove box cocks and add a tab for decomposition out. Yeah, boom. There you go. And then your decomp could have the box cocks thing in there. So you're talking about mine was showing, if you're okay with that, I mean, my department heads, since they, are over the department, they get, they have student confidentiality because they're, instructors of a department. And then I kind of show them kind of where the students are at and what we've been doing and what they've been learning. But would you be okay with that? Like, I'll ask your permission to make sure. But they are university individuals, of course. So, but I'm very proud of multiple people and just the whole class pushing what we're doing and learning. And we've had a lot of people helping people. Yeah, awesome. Yeah, no, I'm really, really proud. We're going to keep pushing the boundaries, keep working harder. Let's hop into the main screen. Let's take a look. Okay, so the issue right now looks to be... Let me see here. I'm having trouble with getting my slider input to adjust the forecast window to connect. Okay. So let's see where the forecast is. Okay. Slider input is called forecast. Let's make sure we have the same thing. Oh, wait. Here it is. Okay. Okay. So time series doesn't take a forecast argument. I don't think that can be put in there. So this right here, so where would the forecasting be done? The forecasting, what we want to make, so we're just going to move this out right here. And let's see, is that still closing properly? That's still closing. Okay. There's an auto plot of the forecast of the time series object. Okay, and that's the forecast function. Okay. Let me take a look to see if everything's running. Okay. Let me see. Oh, no. That's awesome, Cliff. We're going to, if you want, I can keep working away at this a little bit more. Thank you, Cliff, for asking. And it's a lot. And it's like, there's a lot. So we do have, here's the good thing. We've got the data loaded in. We've got the forecast right here, controlling. We've got the button controlling what kind of data we're dealing with. We're dealing with quarterly data. Time series auto plot, looking good. We can set the year. Oh, wait a minute. Okay, no, this because I think the auto plot does this on its own. So if you notice right here, do you see this right here? This is the forecast. Does this make sense that this is the forecast? Yes or no? Like we've got the forecast right here, but now our goal is that this right here, this time series forecast right here, using the time series auto plot, we could move this forward. And my tab is still saying data is not seasonal after I followed all the steps. Send it back to me, Ben, and I'll take a real quick look again. I'll take a real quick. Send me your most recent, and I'll do that. Oh, wait, we have one more after this, right? I think we have a... So you'll be third, Ben. Don't worry, I can stay a little longer today. Like, tomorrow I've got the teeth thing, so yay, teeth thing. Our goal is that this changes reactively to this over here. And I think this is an ARIMA, it's telling me. Oh, no, this is an exponential smoothing. So this is the exponential smoothing right here. So this is an exponential smoothing model. Let me go look to where see the ETS is created. Is it not ETS model? What's going on? That was time series plot. Time series plot. TS plot. Okay, it's forecasting. Autoplot forecast TS object right here. So we can check to see if this is working by doing something wacky. Because you know what day it is. Everyone knows what day it is. Crash, tell us what day it is. It's Wacky Wednesdays. I believe... I'm going to go right here. H is the window by which we forecast. Can you go over F on number 1? Yeah, I'll take a moment right here. Yep. That's wacky. Don't do that. Say, well, why did you do it? I just want to see wacky output. That's why. So let's go back here. Let's get that file. If I have achieved my goal. Bah, If I've achieved my goal, we should get... Yep, we're doing it. We've got it. Oh my God. That's cool. You'd be like, I mean, this is actually a real predictions. And this is something I hate. When people predict too far in the future, your uncertainty gets ridiculous. It's like, how much money will Johnson & Johnson make? And this is monthly data. So how much money will Johnson & Johnson be making? Yeah, that makes sense. I guess it goes that crazy that quickly. You don't predict this many periods into the future. So this right here, and we are seeing that it changes because now this is monthly data. Actually, is this quarterly data? I think it is quarterly data, isn't it? I think it is quarterly data. I could look in a moment. Yeah. We'll double check the Johnson & Johnson data. I'll have to go look. So that's completely wacky. Johnson & Johnson, it is quarterly data. It is quarterly. So the frequency is quarterly. So completely wacky forecast right there. But we have confirmed that this is working right here. So where is this stored? Where are we going to access this? So Ben, this is good practice. Let's make a lot of space for it. Where are we accessing this? Where can we access that information? And let me help you out. I want the full thing to write just to start to where to access that. So, and I'm on the wrong part of it. Here we go. Where can I access this information? Input $forecast. Correct, because this is going to be stored. Great job right there, Cliff. 50 points. Excellent work. Now, this is the issue Ben ran into. Nope, 100% right, Cliff. Great answer. Great work. Yeah, 50 points. And so now this is the issue we ran into because it takes that in as a character. So for another 50 points, Cliff, right here, I want you to tell me how to fix this, because if I bring this down, so you're right there now. You're right there. This is not going to work right here. It's so close. We're right next to the goal. It's like you're blindfolded, and I'm like, you got to make it to the goal, and the goal is the microphone, and you're right at it, and then you go, you're like, no, you're right there. You're right there. That's not right now, because it's a character. That's seen as a character. So what do we need around this? That's why I put a big space for us to work with it. You're like right at the goal. And I'm like, you're right there. Just it's a character right now. It's seeing that as a word. Right there as numeric. Exactly. Great job. Ben's like, I remember that. As numeric. Because it's seeing it as a word. So we're going to go, great job. 50 points, right? I promise the points. I give out the points. Wacky Wednesdays. So we're going to go right here and put the as numeric around it. And you see we did that with the frequency also. Go away. Let's go see if this is working. And here we go. 2 hours later. Load up our data. Data loaded up. Pick the vector. Check out our auto plot. Looks a little different. Decrease font size so we can see more on the screen. Plots, because this is shiny, plots will augment to screen size. So amazing. It's one of the things I love about it. And we go right here. We set it to quarterly data, which it is. We go to time series. Now we get the quarterly forecast right here. And then we go into here and we say, wow. Boom. Working. So we got it right here. It is working. We could go to something more reasonable. We could even have it take, if quarterly, set a default. Like, so if you're going more advanced, which, I mean, I'm not saying we should or shouldn't, but you don't, if you have quarterly data, you probably only want to forecast 4. So I'm just going to show one more advanced thing here. So let's do one thing right here. Let me put it right here. Reactive choice. Okay, if the frequency, right? As numeric. If equals 4. Oh, we need to go reactive around this. trying something right here real quick. If it's equal to 4, if it's equal to 4, then I think we should be able to just store. Then let's do 8. Okay. So this is getting a little more complicated right here. So if right here, I want this, I don't know. I think it needs to go back up here. There's an update. There's a way to update the UIs. I could send an update to the UI, which, so that's what the Y inputs are doing. So I could have, if somebody chooses one thing, it'll update the UI, which that's a little more complicated. I'm just thinking right here. If, yeah. Give me 2 seconds. I just want to code it. If, well, we just put this right here then, right? That'll be interesting. This is a bad idea. Was it forecast? It's a bad idea. Didn't crash it. It's not changing it. Didn't do it. Okay. Bad idea. Worry about it another time. Oh, because I didn't. Let's go look at another one right here. We got some more time. Let's go look at it. We got the first thing done right there. That one's done. Cliff said, I think it was another person wanted me, Thompson wanted me to look at theirs. Thompson, do I have your permission to show yours? And you want me to see, what do you want me to see if you're on track with Thompson? Let me know. What are you wondering about specifically? I have permission to show it. Cool. And what are you wondering about specifically, Thompson? What specific? Discord's weird. About to send my app as I zip up the files. Zipping up the files. Okay. What would you like to know specifically? What are you wondering about? You just want me to know if you're on track? Let me take a look. Here we go. Make sure you cover all the goals. Okay, I see it. Looking, yeah. Let me load up some data. Sure. Be like, this is not working, or this is the MSTL toggle. Okay. Let me go look. Do you have that in here? So the decomp. So let's look at the decomp on the app real quick. Okay. The auto plot's not loading. Here, so I can show it. So right now, you're welcome, Cliff. Anytime. I don't see your plots at all. It's right now we're not getting any sort of plots. Oh. Maybe it's crashed. It says UI not found because I was like, something's weird about this. Okay. Oh, do you have your midterm title page? Can you send me the midterm title page .rmd? Can you send me the midterm title page .rmd? Oh, you might have sent it in the previous thing. Midterm title page. I'm bringing both these in here. You sent a zip. Okay, bringing both them in. Place files in its destination. Good to go. Okay, let me go back. Okay. And let's go back to the main screen. Okay. Hey, I like the backgrounds. Looks pretty cool. I was like, oh man. You might make the font a little the green on the blue might be a little, this over here looks pretty all right. You might make it, don't worry, that's just aesthetic stuff, but it might be a little harder to see. You might just, don't worry, I won't take up points for that. It's all aesthetic choices. Like, you can just change it. But it looks like he did a color gradient on this, which is pretty cool. I want to see where he did that. The color gradient. So there's the gradient linear. Yep, there's the set background color. Nice job. So he did a linear gradient direction. You know what we're doing here. Go. I need to get permission to play this. You know what we're doing. We're going full on right here. We're going Rocky Top. Oh, God, that makes it impossible to see. Where's the, you got the body color right there. FF. Sorry, I need to stop having fun with this. Oh, that's, okay, there we go. Oh, now we got this problem. Where's that teal being called? There it is right there. I'm going to go FF8200. Okay. Hey, now it's Rocky Top app. So, and what were you wondering about? This is looking pretty good. Thompson, this is looking pretty awesome right here. Why not Rocky Top theme? I just need my button like. I don't think they'll copyright me for humming it, but if I play the song, they will. You can't do that on YouTube without getting hit with a copyright strike, even if you work at the university. Probably. What are you thinking, Thompson? Feel free. I can start loading some stuff up here, see on how it's working. It'd be cool if you had a button to change themes. We might be able to code that. I can code that in here if you want. The decomp tab. Let me look at the decomp tab, and then let me actually put a button in here to change theme. I bet I can code that. I bet I can code that on here. I'll speed run that here in a moment. Let me look at the decomp. And okay, let's look at the decomp tab. That'd be awesome. BeepR can play music, so there's probably a way to get it. Like if you load the app, like every time you load the app, you hear like some. None of this is time series. It's just having fun with coding, and that's part of the point of coding. The decomp. Okay, wait. Series is not periodic or has less than 2 periods. Let's go to the time series settings. Johnson Johnson AS4. You're gonna be med decomp. Oh, we're getting the decomp. Oh, it's in Plotly. Oh, I love some Plotly. Oh, Plotly. Let me go away here. I noticed. Oh, whoa, yeah, man. Ah, those are so tiny. Yeah, I mean the residuals, as in the boxes being tiny right here. Pew. The boxes being tiny represent that the let's go to real data. We were looking at a vector of numbers that go from just year. So that data, yeah, obvious. We want to look at some real data here with some real seasonality and a real trend in the data. Oh, and you got your MSTL. Wait, what's wrong? This is where a box Cox might come in some use. So if you were to add Thompson, this is looking absolutely amazing. Great job, Thompson. And then what's your value right here changing? I don't know what this slider is connected to. Has an option. It looks to be working. It looks like you did an if else, and you connected it to it, but that looks to be working. If you look, the seasonal pattern is showing some multiplicative values right here. There's the data. Data should look, yeah, you see the data looks the same. Data is not going to change. It's just that they're not doing the plot right there. The T window, oh, so that's only going to impact the first one. Ooh, and that's where it's estimating the los. Probably, and if you look at the literature, oh, and you put it to odd numbers. Oh, you are a genius, like we're seeing today. Got to have it on those odd numbers. This value right here for the T value, T window value, I'd probably, and our residuals are getting a little bit worse here at the end of the model. Once again, box Cox might come into some use right there because we're seeing increase in residuals. Seasonal component is very small in this. This is looking excellent. Ooh, I don't know about that. There's a lot more trend in this data than seasonality, which is interesting. The seasonal component's still pretty big. I think it's because of these large residuals here at the end that we're seeing the scale of this increase. We're getting a pretty big -3 residual on that, and you have to love Plotly because of that. I was looking at it as a -3 residual, and if you trace this up, that is on this point right here. This point just has a very big drastic pull away from the series, and it does follow its seasonality, but in recent years the seasonality is growing, so maybe some multiplicative values on seasonality right there. So switching over to, and you are seeing, if you throw a lambda in here, that might help because we're still seeing the remainder on the residuals. One bummer about this plot, the multiple season decomp, is you are not getting as much control here on the way it's doing the Los method for the trend. So we should see massive changes in the trend right here as we go through. And now you're seeing the trend is less smooth because when you increase the trend window right here, you're doing it over more values. So when you go to higher values, you should see a smoother trend across it. We are just seeing a big, the seasonality is not showing up as much. We're really seeing a lot of it's in the trend. That's where we're getting a lot of information. Got some big residuals towards the end. A lot of good information if you know how to read the plot right here. And it doesn't have values, but it's all the plots. Thompson, this is looking absolutely stellar. One big change I would make immediately, though, is I would change the default value on this, like with literature. So T window, it's pulling input T window. I would immediately change this to by, and then we should put, what is it? My brain's breaking. You probably have it elsewhere. Value. It's value. We should be able to go here, sequence, choices, and we should be able to go value and go to value 9. Another argument right there. Should work. Hopefully I didn't break it. We'll just put it to a value of 9 for the Los method of smoothing. So this is calling the Los, the regression where we take kind of an average of the values or a weighted regression line and then use that regression line here to make a prediction for that point. And going in here to the Johnson Johnson, really absolutely stellar job. I love the themes. Then we're going to add some color. Then we're going to do a 474. Okay. So we got the data loaded up again. I guess I could have just looked at the decomp. What? Oh, data is not periodic. Ah. Okay, I broke it. Choose value. It's not. Can you go over 1G? You bet. Yep, we'll do that here next, Trace. We're going to do a quick, we'll do one more thing with Thompson's thing right here. But Thompson, everything you have looks to be working accurately. It is changing it right here. Ooh, what's going on? Oh, because haha. So funny. Make sure you're analyzing the actual data. It's under the second column. I just don't have it named. But no, we can switch between these two options right here. Looking absolutely amazing. We're going to try in one more thing right here. These are, once again, just the fun things you can do, not what you'll truly be graded on. Background color equals this right here. See, always this code right here is a lot of fun when you call this. Body color. Okay, so we need to add. Let's go and look at one thing. Let's go to Shiny Widgets. And go to Shiny Widgets. And let's go find ourselves a Shiny Widget. We'll put 5 minutes on the clock. If I'm not done in 5... Can you go... Yep. If I'm not done with this in 5 minutes, we'll switch off. But gotta have some fun right here, right? Let's go find ourselves a Shiny Widget. We're just going to do a 2-color selection. And the 2-color selection... Oh, we don't want that. We don't want that to stack. That's not good. Ooh. Should be good. Yeah. I can do this. Okay, got it. Okay. Should be good. Let's go in and set background color, all this good stuff here, main panel. So we want to go down to the bottom of the side panel. That's where the side panel ends. And so we want to go here, throw this in, see if it works. Once again, every time you put something in, it doesn't work. We should have been inside of it. Losing my mind. Probably. not sub-indented correctly. Not where it should be. Ooh, we're in the file input. No, we're not in the file input. Let's go right here. Get mad at me if it wants. What are you doing? What are you doing? I'll be... Why is my switch input not going there? No, that should be there. It's gonna break it. What is going on? Gotta be careful. Have a working... We didn't get that to work right there. We're gonna run out of time on this one, everybody. Comma, re-break it. Let's make sure everything's running. Because I've made a few changes and I might be running from an old UI. Maybe put it at the top. I've seen issues with that. You know, we could. I think you're right. Let's go put it at the top right here. Title panel right here. You know, you might be right. Sidebar layout. Let's go right here. Go ahead and do that, right? All right. I've seen issues where... Oh, yeah. Great job answer right there. Yep. Sometimes it just has interference. Okay, we got it. We got our button. So we'll have it set to true. And what we'll do right here... Can it see this? Okay, wait. I'm going to try something. If this is a bad idea, input $sign ID 007. There we go. Then run this. Else. Probably not a good idea to put these up here. Okay. It's not. It's going to get super mad. Didn't get mad. Not doing it. We need to send that down to the... We got the button on the screen. How much time we got? No, we're out of time. Put in 2 more minutes. It's 30 seconds. Okay, so... See, it's being done up here in the UI. I mean, yeah, in the UI, so... I'm just thinking because I wanted to just change the color right here. And it's a UI thing. So I'm wondering if we can actually reach it. So we got the button. And I think it's a UI update. You have to do the UI update stuff. And so there is UI update. So update selection. So you might have to do like an update... So it's probably, I'm guessing, update no slider input. Like it's probably update. Does that make sense? Update checkbox groups buttons. So what is the thing we're working with right here? We're working with the tag style. I don't know if we can update that. I don't know if there's an, watch there be update tag style. So you can update depending on what happens. So right here, it has to have like a session. So yeah, I think it's a little more complicated because the UI has something currently in it. So we need to then have an input go down. We need to have something input in the UI, have it go down into the server. And this is actually where you create like a session folder right here, or a session group. And then the session updates the session. So unfortunately, this is a little more complicated than I would want. and I gotta update my shiny skills. Just thinking about how this works right here, where it's gonna update things, and this is how reactively we get the choices. So what you're seeing right here, that's the end of the time. We're gonna let Trace this question now. The reason when you change a data set, if you load in a data set, no matter what your data is, update object, oh, not found. What's going on there? If you load in a data set and the data loads, I'll have to look at that. I'm gonna ignore that this just broke right here. Everything's breaking. Let's run an actual. So we got a button in there. Yay, button. Yeah. So when you load in data sets, this updates right here. So if you look at the code, once again, we don't need to do this. It's just for fun. It'd take a little bit longer. I have to look around a little bit. But this right here option for the Y variable is what the update server is doing. And then if you load in a different file, like let's say the Nestle data. Let's hope the Nestle data works. Here's the Nestle's data. Yeah. Oh, Nestle's data is a bit weird. I think it doesn't have the column header. Oh, why is it being weird? Let's load in the J&J file. There we go. Yeah. So if you load in the J&J file, it's updating these right here. So if you go to a time series of it, you can do all this good stuff. And then we need to put in the periodic. And then you could put a warning message or whatever, but yeah. It's good. Function called argument1. Well, maybe my J&J file is wrong. We'll look at this later, but yes, everything's looking good. Let's go back to the main screen before Brian just breaks everything. Breaking everything. I won't try to break your app too much. We're not meant to have perfect app. We're meant to have good apps. And then we just keep working. Let's go over 1G. I get an error making the subset. So this is 1G for 474. 1G for 474. Let's go take a look at that. 1G. A, B, C, D, E, F. Wait. Where's the 1G? Did we just say, oh, it's 2. Using a single line of code, print to the screen 31 rules that involve black-eyed peas and pink. Doesn't have the iron name. In the consequent right-hand side. Is that the one right there? Let's take a look here on the main screen. So I think we're still working off the rules earlier. Take a look at the earlier portion of this. We should have everything loaded in. So I think we created rules 1C. Have we changed our rules at all? Trace, tell me if we've changed our rules throughout this. I don't think we changed the rules. We did this earlier. Take a look at how we got the rules. And let's go take a look. Awesome job, Thompson. Great work. Absolutely amazing. Just change it to Rocky Top. You don't got to change it. You don't change it. You make it however you want. Before you log off, could you check my super file super fast? I still get the data is not seasonal error. Yeah, send me your most recent. And I'll take a look because little changes. Yeah, Ben. Take a look at next here. I think we did the rules one time, correct? And so these are the same rules, unless I don't think we changed it. So we're going to go in here and so use the single line of code, print to the screen, 31 rules. Okay, so we need to go. One of the great things about this is we're going to go and take certain rules. We're going to use the subset on the rules. So here we are. And we're going to take a subset. There we go. Let's go down here. A lot of things right here. Actually, this is basically what we want right here. And right-hand side. We don't want that in right side. Code's got a lot of good stuff. Let's just review how to do this right here. So when you take a look at this, pretty crazy. This is just your subset. You just call it just sub. What are we subsetting this time? We're subsetting our rules. 1C. These are the rules we have. Now we want the right-hand side. And it has to have rules involving this or this. So we want an IN. And we want boom. Boom. Delete all this off. Really? Really? There we go. And we don't need the extra bit. There we go. It's interesting. You have to call the right-hand side, left-hand side, or items because these don't autocomplete. Really easy to forget what they are. We should work. It worked. Let's go inspect the rules, print to the screen. How many rules do we get? We got it. Is it making sense, Trace? Sometimes it's just the smallest of things, especially. These are the 31 rules that apply to either somebody wants to know how people would be more likely to listen to Black Eyed Peas or Pink. Yeah. Why? So why for 1D do you use music? Let me look at 1D. 1D says you should find that one of the top rules in terms of lift is Britney Spears, Selena Gomez, Miley Cyrus. Like, how does listening to Britney Spears and Selena Gomez influence someone to listen to Miley Cyrus? How many listeners like this set of 3 artists? So actually, we can find the answer to this really easily. We have the rules up here previously, and the answer to this question of how many listen to all 3 of them is this right here. Does that make sense? So we actually know the answer, but we're going to do it with some more code right here. And this is where we need to use things like item frequency. So we're actually going back to the main music, which the music is all the transactions of things people listen to. So if we go to music and we go to item frequency of music right here, we could actually see how many people listen to Miley Cyrus. And to find out how many listen to Miley Cyrus, we see right here that 14.4% listen to Miley Cyrus. But you said, Brian, the answer was 5.49. But that's everyone who listens to Britney, Selena, and Miley. They have to listen to all 3 of those artists. And so what we need to do is we need to go to a sub. Watch, today I'm not going to make a mistake. Subset. And we want to go to the items. No. We want to subset music. That's what we want to subset. Then items is a special thing right here, which is going to subset the items. And then we want %AIN, which means they have to have everything. And then we're going to take and put in quotes the names of the artists. So this says you have to listen to every one of these artists right here for us to consider you in our subset. And it says error. It's mad at me. It's always mad at me. Let's break apart the code a little bit here and see what we made error-wise. %AIN%. Error. Labels are not unique. Let's go a little slower. Oh my gosh. Do you see it? 50 points on the line. Who texted me? CVS. Who texted me? What's the error? What is the error? I'm ready to go. What's the error? It's always user error here on Stat 201. Yeah, Discord me. We're gonna look at Ben's, and we could got a moment here. We'll look at Cliff's too. Great job, everyone, working on this. What is the error? It kind of told me. Forgot about Britney. Britney, good deal. And so it says to do it in one line of code. So I'm gonna take off the subset right here. What we could probably do, does it say how many? We're on 1D, right? How many listeners listen to all 3 artists? Write a line of our code that produces the number. We can $sign about $sign. Hopefully that's a typo there. I think this will work. Is it 100? It's 100. It might. Let me find out. Let me take a look at your code right here. Good job, Ben. Chat. Okay, so Ben is doing very similar. Do you get 100? Graphics error. So you're doing a which. So you're getting whether or not they listen to it, true or false. Is this running? It's mad about this. It says error in evaluating function which table contains an unknown item label. Oh, I think here we'll double check. Okay, that's right. Oh, there's an error here. Is there? Maybe. Oh no, Britney Spears. Britney Spears. Britney Spears. Yep. Works. But it's not Britney Spears. It's Britney Spears. Great job right there, Ben. Selena. Was it wrong also? Was it? Oh, it's Selena Gomez. Selena Gomez and Britney Spears. So sweet. Works. I was like, theoretically that should work with Selena Gomez and Britney Spears. Smallest of typos, I make them too. Code crashes, nothing works. That's the way it goes. What else do we cracking me up today? Let's go take a look. I think we had a few more questions from, and great job, Ben, working on this, writing your own code for it, making sure it makes sense. Because Ben's going inside of here, finding out if we have people who listen to, these are trues and falses. Then he's finding out the positions of the trues. Then he's going back and returning. Frank, at this point, you can actually delete this off right here. You can now just return this, because if you know just the positions, the next thing you did was you returned the playlist items, or like the music, the transactions, which are the people's playlists. So if I were to keep this around it, which is fine, it's just going to return the playlists in those positions. So now these are 100 transactions right now, because these are the 100 playlists that contain, like, these playlists are now a transactional playlist, and then the length of the transactional playlist. But you could theoretically just remove this off to find out how many positions there are. And so that works also. Lots of answers, about 1 billion ways to code things. Let's go take a look. I think it was, who wanted me to check out next? I think it was Ben. Did you also have a problem? I think, Ben, you were first. Ben, you were first in line for... You're welcome, Trace. Great job working early on this. Just, you got to hear it about 20 times. That's why I repeat things. It's not because I'm verbose. Just put verbose to false on Brian. It won't work. It'll say, argument not accepted, not a valid argument, not allowed in function, Brian. Yee. All right, let's go over here. Ben sent me it on Discord. Remind me of the new problem, Ben. Remind me of the current issue with the app. Current app issue is what? Current app issue is what? I'm asking while I'm looking. I might remove out the EX7 bike stuff that might cause issues. I just saw it at the start. I'm not saying it's horrible. I'm not going to take points when we grade it, but should take like 30 seconds. Data's not seasonal. Okay, cool. Let's take a look. Okay, I got it on the main screen. Ben, second, show it. Okay. Data's not seasonal. So make sure to put in a frequency. That could be part of the issue. So make sure to have a frequency in there. That might be the issue. Cross your fingers that that's the issue. Okay. Got the data loaded. Going over here to converted time series. Data's loaded up. Time series plot. Going over to seasonality. I think that was the issue. 30 seconds. I did it in 10 seconds. Boom. There you go. Very good point. You could put messages to someone saying, like, you know, you'd have to do like some ifs or something, you know, like if this, say this, you know, put this output here. But yeah, a lot of interesting stuff could be done here. But yeah, that was the issue. On your frequency, make sure you got a frequency, and then you can go over here and go to your seasonality and look at seasonality. You know what I do like? Just saying. Just saying. Polar. I do like the polarity version of it a little bit better. You don't have to do it. It's everyone's call. I like the polar version. I wonder if we can... Nah. Maybe. Ooh, that's pretty. That's just a pure spiral. That's a pure additive series. I mean, it's just a... There we go right there. So, it depends on the day. I remove the option for daily. Yearly causes issues sometimes as well. Yeah. And then this is kind of inspired... Oh, because... So the frequency right here, this is one way of doing it, but you can also change it to where it's... you could have a drop-down menu. So you just have to watch the value you put in, because... it's a horrible idea. Ah, it's mad. Yeah, some of them will get mad. This data doesn't have this format. Yeah, it's not that kind of data, though. Every time I see an error, I freak out and go right back to the code instead of looking for small. Yeah, it's tough. Yearly equals 1, date and daily equals 365 exactly. So you just have to make sure your data has that sort of structure to it, and then you can get some sort of seasonality out of it. But great job right there, Kayla and everyone else. You can put in a min-max on it too. Yeah, exactly. So we can make sure people don't put any values outside of it. We could put like a drop. I really like the drop-down menu. Like, I think, Kayla, you did that. And that's why I've suggested to people from now on is like putting in the values, allowing people to choose from a drop down, which it removes some flexibility, like in case someone wants to do some interesting stuff. And there was actually, was it W11? There was some decomp stuff I meant to mention today, but we were doing some examples at the end. There's just some advanced decomp. So if you want, how much show it? Really great resource over here. I'll show it on the main screen. But if you want to go into more in depth on decomp, I'm trying to use only the most recent stuff in this class, not teaching by stuff we did 50, 20 years ago. So here is the guy who basically wrote all the packages, and you can see like 2009, like all the stuff we're dealing with right here. Here's the X11. It's X11. 2016. I mean, this stuff is super recent. This is not like what we were teaching statistics. Like, I'm not even joking. When I was in the master's program, which is not that long ago. Okay, it's a little bit a while ago. But when I was in the master's program, we wouldn't have these kind of algorithms to run with X11 decomp. So I was going to kind of get into this stuff today. It's just a better way of doing decomp. It takes into account like trading days and holidays and certain things. So, but includes a few extra steps, overcome drawbacks. In particular, the trend cycle estimates are available for all observations, including the endpoints and the seasonal components. Is allowed to vary slow over time. Alexion has a sophisticated method for handling trading day variation, holiday effects, and the effects of known predictors. It handles both additive and multiplicative decomposition, so it can do both those. The process is entirely automated and tends to be highly robust. Robust means it handles outliers well, which means outliers won't overly influence the model. And level shifts, which when we're talking about, like it goes poof, like that, a sudden shift in it. But to do it, all you're going to do is just pass your arguments through this right here. That's it. That's just the decomp. So that's where the decomp happens. You're just taking your data, passing it through, and you could put a fit to it. So it's just season X11, and this is the argument right here for X11. I don't like the way they write that argument. So we'll just take a look at this, and I think Cliff had a question next. So we could do, if you don't want to do it the dplyr way, we should be able to take our Johnson & Johnson data, just our classic data set, and all you're doing is throwing it into the decomp here, theoretically. And we should decomp it. Oh, look at that decomp. There we go. And there it is right there. I don't like the way that decomp looks. Should be correct. Yep. And we can outsave the fit on it. I don't like left arrows. At this point, I'm not going to use the left arrow. And then right here, we can plot it. Cool. But we can also, we should be able to get remainder out of it. You going to give me a remainder? No, it doesn't like it. It's a fit object. A list of one. Whoo, look at that. Interesting object to work with. Really? That is not a pretty object. Not the prettiest of thing it saves. And once again, these are things that, so we should be able to auto plot it very easy, they're saying. And I was going to get into this today, but I didn't want to go too many topics in one day. Ooh, what's it not liking? Object type list not supported. Yeah, well, they did it. They're passing it through. Well, let's do it the ggplot way. Okay, you want to do it the ggplot way? I mean, not the ggplot, the dplyr way. So using dplyr, we should be able to just change right here their Johnson & Johnson. And it's yeah, it doesn't like it. It says object of type list. So what are they doing slightly different right here? Do I not have library seasonal loaded up? Did I reset R recently? This is why I have all my examples ready to go. I'll take a look at Cliff's question here in a second. When something doesn't work, it just drives me nuts. I don't see it. So the fit right here. Let's run their data. Okay, it works on theirs. Let's look at what they have for their data. Okay, it's monthly data. Oh, no. 50 points. Gosh. Everything I had was working. What's the issue? 50 points. What's the issue? You should see it. Why is my code not working? I was like, everything I have theoretically should work. But what's going on right there? That's the issue. So why is this code not doing a decomp properly? Why is the decomp not happening as I pass through this object? So why is the decomp not happening as I pass? Well, it's not really the fit. Look at the object. And so why is this object that's passing through? This is the previous object. This is the one that worked. This is the one that doesn't work. So I can kind of give away the answer. And the answer is going to be this. That's the answer. Oh, no worries. So I'm trying to pass a data frame through a decomposition and save the fit of the decomposition of a data frame. We don't decompose data frames. What do we decompose? And somehow my Johnson & Johnson got changed here. We decompose time series vectors, and now it works. So we decompose time series, and yeah, that was the issue right there. It was it was not a time series. It was a data frame, which I didn't know that. I was like, so I think something happened in the background. We've manipulated Johnson & Johnson in a lot of ways when we read it in. And so I think one of the apps was creating a Johnson & Johnson data frame, not a Johnson & Johnson time series vector. So the class of object in R is very important because when Johnson & Johnson existed as a data frame, it wouldn't pass through to the decomp properly. And that's why I was like, if you rewind the tape, I was like, well, that's some weird output. I looked at the fit and I was like, that's weird. I think that's my original fit that was bad. And I was like, what's going on with that? I was like, well, I guess the X11, which I ran a little bit last night. It's over here in the my decomp notes. I ran the X11 a little bit when I was making sure everything Z11, X11. There it is right there. I was like, everything ran, and then I don't want to do examples I haven't done a bunch of times. So I was like, we'll leave the X11 out. But so Kayla, this is basically a more robust way of doing it. It's also got some other options. If you look at this right here, there's other ways of doing this, but this right here is like super advanced decomp. So if you want to go even further with decomp, like this is next level decomp. And I just want you to see once again, this stuff is super new. X13, so maybe they're even beyond X11, and that might just be the series by which they've made this. But if you're looking for the most modern and recent stuff right here, which is what I'm trying to get this class to, I'd love it if 5 years from now I'm teaching even new things. But so maybe I'll mention this at the start of tomorrow. But this is like your super advanced decomp right here. And if you want to go deep into it, just start trying to optimize this one, and you'll start optimizing even further on your decomp to go up here. But once again, this is not basic decomp anymore. This is it's going to have like some specialty stuff, especially for like stocks I was reading about. So a lot of people are using this. Hey, if you want to do stock stuff, probably this sort of stuff right here, which is going to control for kind of holidays and different things that would have inherent variation in them. Does that all make sense? Like this right here is really advanced. As in, how recent is it? We're talking in the last 3 years. And to think, you know, that's what statistics is doing. So there you go right there, Journal of Statistical Software. So and that's the great thing about R is that these things are being updated and we're using the most modern techniques. So I try to get us there, but we have to learn the basics because look at what they based the model on. Look at that right there. So we got some ARIMA involved in it. So then we have to know about the autoregressive integrated moving average. I think, Cliff, did you have a question? And then seats, I was reading up about seats. I think that's your exponential trend, all that good stuff. But all these acronyms right here, seats right here, so much stuff. It's absolutely crazy. Regular, there's the, man. I think next week we'll be doing dynamic regression, which is right here. And those are the endogenous, I can't even speak, variables for regression. So we can actually right here take an X variable that is associated with it. So this is what's really neat about the XReg right here is you can pull in, like, especially if you think about the bike data set, the bike data set has X variables that are associated with it. So that X variable can become a predictor in the time series model. So now we're taking the time series model with it and adding a regression backbone to it. You're welcome. Awesome stuff right here. But This is more advanced. It's going to go through, give you so many options. Regression AIC test. We've talked about AIC, transformation functions, outlier, automatic outlier detection set equal to null, all these good things. Just composite and nameless is just crazy. And then we get the same sort of plots. You're basically running the same sort of thing, and you're getting the same sort of analysis, and we're seeing where the bad residuals are in there. Yeah, and that's saying the irregular, which are the things we really can't account for. Let's see. Did Cliff have a question? I might hop off and go to Discord. See if people are still here. But a lot of good work today. Got to see some X11 decomp. And once again, I said, trying to bring us up to the most modern stuff so we can see. But you can't do X11 decomp unless you know what decomp is. And then you just go to better decomp. And the book I showed earlier, which is a lot of what I'm getting, because this guy wrote the forecast package. So let me drop it in the chat again. If you didn't see it, I'll pin it. This is the book right here that I'm basically using a lot of our notes and material from. And he really, I should just suggest that to people, that like all my notes are basically crafted from what this guy's written, because he's writing the most recent, like he's quoting 2018, 2016, Everything he's got right here is, and I bet you he updates this. So it's not old. This is new stuff. And it's really awesome. The seasonal package for R. Boom. Seats decomp. SEAT stands for Seasonal Extraction in ARIMA Time Series. What? So we're extracting the season from an ARIMA. ARIMA models are discussed in Chapter 8. Yep. This procedure was developed at the Bank of Spain and is now widely used by government agencies around the world. The procedure works only with quarterly, monthly data. There we go. This is limitation. So seasonality of the other kinds, such as daily data, hourly data, weekly data, require an alternative approach. So the seats decomposition. The details are beyond the scope of the book. But Dagum and Bean, I cannot say these names. Those names. Here we'll only demonstrate how to use it via the seasonal package. And what do you get? You get a decomp. So it's doing some advanced stuff in the background. It's got limitations, but we can see what the decomp is giving us. We can break down the original data into the trend. Probably not using the LOS method right there. And I would guess not, because it's more advanced. Seasonal, and depending on how we let it change the seasonal pattern. And the remainder, ooh, look at that residual. Looks to be that right there. Little spike right there, but it did not expect that. I'm tracing up properly. Yeah, look at the white line right there. Yep, it's that point. So that's your very irregular, super irregular right there. But yeah, super cool stuff right here. Just really good stuff. 1990. Yeah, and that's what we're using. Just very common, more generalized usage of it. Yeah, and then you get some math equations. So I've shown some, but yeah. And we did some forecasting today with it. So we did the end right here with forecasting. I was like, I just don't have time to go through all of it. Well, it is time for office hours to end. With that, take a look at the book, read through, and I think I'll make it more clear, especially next semester that we're using the book, because I hate for people to be like, the slides are limited, which I think they are, but knowing that we're using the book is maybe a help to individuals, and I'm going in and just creating my slides to go through and then going through a lot of the code in the book. I don't want to do the exact code. My code is usually on like data sets we use consistently. But that's got it. We'll be back tomorrow. Until then, bye for now, everyone. Bye!